Okay, so welcome everybody to the Explore the Possibilities of Generative Design for Autodesk Inventor. Today's presenter is Mark Flayler, who is our Senior Solutions Consultant here at IMAGINiT Technologies. So with that, Mark, I'd like to hand the floor over to you.
All right, thanks, Lori. Thanks for the introduction. Essentially, we're going to be looking today at the Autodesk Generative Design technologies. We're going to be looking at the capabilities inside of your collection, including the Autodesk Inventor software, as well as the Fusion 360 software. And we're going to try to kind of dispel some misnomers as well around generative technologies and what's available to us. So a little bit about our overview here. We're going to go through for this webcast. We're going to do a little bit of an IMAGINiT overview and update with some things that have been happening with us. We're going to talk about the overview of generative design technologies. We're going to talk about the Inventor shape generator, as I mentioned. We're going to see how generative design performs through Inventor and Fusion 360. And we're going to talk about some last minute things here like product design and manufacturing collection notes, some things which are important around this technology, as well as some Inventor tips for the shape generator inside of that software. And if you're a Vault user, you definitely want to stick around for that one. So here at IMAGINiT, you probably have seen this spiel many times before if you've attended our webcast, but essentially we are here to help you discover technology solutions, optimize those, and help you increase your productivity. We are definitely not a company that likes to push a box. We do like to ensure that our solution that we're providing can make you more productive and basically help you out with your daily activities and reduce the mundane fun that is CAD work. We are a RAND Worldwide company, so we actually are underneath the RAND Worldwide umbrella, and we have a couple different arms. Of course, you know IMAGINiT quite well. We also have Ascent, our courseware writing company, which does all of the professional training manuals for Inventor, AutoCAD and manufacturing and building products and such, as well as PTC and Dassault software. Now, one of the bigger updates to talk about is we've recently acquired a whole new set of offices. So all these new blue push pins are new offices we have available to you. So if you have different satellite offices in these locations, or if you find yourself in one of these geographic areas, definitely pop in, say hey, or give someone a call and say, hey, how's it going? I didn't know you're in the area. But we do have a lot of new offices popping up. Some of them will be merging together where we have overlapping push pins. But essentially, we have a bigger geometric or geographic footprint now. So just want to point that out to you guys as well. We do offer lots of professional services, so I'm not going to read through these, but you can all see them on screen. We do really focus ourselves on being a professional services provider first. We also offer a lot of self-paced and e-learning and online training options as well. So we have Productivity Now, which any one of our clients can become a free login for that portal. Inside Productivity Now, you can actually have more enhanced paid support for video enhanced e-learning and courses as well inside of there. So some fantastic benefits for being one of our clients. Now, once that's out of the way, let's go ahead and jump into Autodesk Generative Design. So let's talk about this technology from a 1,000-foot perspective here first. It's essentially a design exploration technology. So you can simultaneously generate many CAD-ready solutions based on standard manufacturing constraints and what you want your product to perform. And essentially, it's going to be taking some machine learning algorithms with some unlimited cloud computing power. Everybody knows about how unlimited the cloud is. Plus, the most important factor is you, the human that's going to go through and set those criteria and understand what that design is going to be about. And this can create hundreds of thousands of different design options. Now, some of them will make absolutely no sense. And that's why the human is in the equation, to say that, wow, that was really out of left field. I don't know where I got that one. That silly computer just didn't know what to do with that. So being able to kind of go through there and identify these different possible solutions and see what works best is a really important aspect of generative design exploration. So let's talk about why this is important. So some traditional design exploration, and I apologize for that being a little small there, but essentially you're going to go through different concepts and different validations to produce your product, and that might round trip itself backwards and go through different manufacturability and evaluation reworks in order to get back to that same validation and producing of your actual part. So this whole process through the iteration and design to production phase can sometimes take multiple loops and multiple tracks. Sometimes these aren't avoidable, but we definitely want to mitigate as many of those as we can. So how does that really help the process? Again, so kind of talking through it again, creating the validation, producing it, getting the manufacturability. So what does the actual generative design do for you? Wow, look at all these bubbles. Look at all these different multiple validated manufacturable options that come through design exploration. So again, different hundreds to thousands of different types of design iterations you could possibly create. Well, as a human, you can look into that and say, well, this one here kind of makes the most sense based on my design criteria to produce that part. So this might get you to a much faster design to production phase than before. And as you can see, if you overlap that with the previous slide, that the amount of rework could drastically be reduced. Now, I'm not saying everything is perfect. Again, this is kind of holistic in its nature, but you might be able to go back and make a second or third design exploration in case something changes in your experiment. But that's really no different than normal design work. So this is one of the bigger benefits of the design exploration you get in generative design, but there's also some other benefits we're going to talk about later in this PowerPoint. One of the biggest things I wanted to point out, though, is there's some big misconceptions around the technologies we have available to us in our product design collection. For instance, the Inventor shape generator versus Autodesk Fusion 360, they are actually drastically different. Inside of Inventor's shape generator, you basically have a topology optimization, which also exists in Fusion. This requires the user, the human, to invest time in fully confining the problem and determining the experiment. Anyone who's ever dealt with the Inventor FEA environment can find themselves right at home inside of the shape generator. And it's typically designed for lightweighting. So I don't really care too much about how it's going to look when I'm done. Let's just run through these constraints and see if I can reduce the weight on it. And what you'll get out of a topology optimization is you're going to get one solution, not hundreds of thousands. So you get one solution based on your experiment that you're going to have to then go back and iterate multiple times to change what that one solution might be. And it's going to be totally dependent on accuracy of that confinement of that experiment. And as I mentioned, it's really not typically manufacturing aware. In fact, when I show you shape generator, it's going to look a little bulbous, a little like some chewing gum in certain areas that you don't typically utilize for manufacturing processes. Now, more on the generative design side of it, which is really the big power that we talked about in these previous slides, is you have more of an explorative methodology that has a goal-driven approach, and it does this through multiple AI-type things. One of the biggest things is the manufacturability is taking into account during the ideation, and inside of Fusion, which has built-in manufacturing capabilities with milling operations, that it actually can take in consideration some constraints of the actual producing of the part. Also, you can do a lot of trade-offs for performance and go beyond lightweighting. So, mass is definitely one thing you can target with generative design, but it's not the only thing. You can also go for stiffness as well and some other things. So you're going to get a lot of different outcomes with generative design. One of the best case studies that came out when this technology first surfaced was actually presented at Autodesk University, and this was an Airbus Bulkhead. The primary goal of this was to lightweight the product so that, obviously there's less weight on an airplane. Why do airplanes care about less weight? So they can charge you more for a bag that they throw on the plane. So if I can reduce the bulkhead weight by 25 to 30 pounds, that's an extra bag I can charge for. Now, the intangible benefits that came from that, though, were reducing the component count drastically. So let's say a traditional bulkhead might have 150 different components in it. If we can get that down to 5, that's a lot less sourcing, a lot less individual piece components and fastening and connections or welding that has to take place to get all those parts together. It can also reduce the overall machining and cost as things scale. So again, we can see quite a few variations came of this, but realistically, when you start looking at what this bulkhead needs to be, you probably don't care too much about some of the mesh things inside of it. Obviously, if you have wires that need a route somewhere, you're going to pick an option where the wires can route through somewhere, while other existing components can bolt to it, things of that nature. So there's still some thought process that goes into it. But in general, reducing that weight and keeping the stiffness and stability or strength high on this component was the main goals. So let's take a look at one of the first technologies. We're going to jump into discussing Shape Generator and how that operates inside of Inventor. So again, this is a topology optimization where you can take your geometry that you see here, this first image, and you can run through and create a mesh for that image, and then take that mesh, promote it into your solid environment, and then use that as a kind of a guideline to start reducing material where it makes sense. So really ideal as a lightweighting measure, but it still maintains certain things based on your experiment setup. So your general steps here is when you start the Shape Generator environment that you're going to define your material. And of course, you can do different material studies. You're going to apply constraints and loads to this. You're going to define your Shape Generator settings for how the experiment's going to run, what your target mass might be. You can also set preserved areas and define your symmetry inside your model, because clearly you don't want something that's traditionally symmetrical to not be symmetrical when you're done. Then when you run the Shape Generator study, you'll get that mesh that I talked about there. That's actually that second image. And then you can promote the design and essentially make your modifications. So let's kind of take a walk through this a little bit. Now, the Shape Generator tool, it's actually a command called Shape Generator, located on the Explore panel inside of Inventor. And this is a little bit older interface. I'm going to show you how this looks in 2020. But essentially, the environment here looks very similar to FEA, where you can create a study. You can assign materials and constraints and loads, and basically everything up to that point really looks like the Inventor FEA environment. But next we have the goals and criteria, preserve regions, set symmetrically our geometry for different planes, as well as adjust some settings. So let's kind of walk through some of these things. First off, the material assignment. Got a little bit of an overlap there on the slide. But essentially, we're going to assign the material there. The original material of the component will actually automatically appear here. And then you can override the material. And what's great about these studies, you can copy and paste inside this environment to create studies 2, 3, 4, and 5, and change your materials and see what that does to your mesh. But that's a nice way to kind of iterate things and make small adjustments. You also have constraint assignments. So you can do fixed, pin, or frictionless constraints. That's going to help you actually define how the model will be constrained in its working environment. When you do your loading assignments, you have force, pressure, bearing, moment, and gravity. There's also some additional ones underneath that loads expanded panel, like for things like remote forces and such. But a load must accurately define how the model will be loaded in its working environment. And this is where we started talking about, setting your experiment. Well, one of the biggest things about any FEA study, and also Shape Generator for that same reason, is making sure the data you're putting into it is valid data, and that you're setting your experiment up to give you the result that you're expecting to get. Sometimes I might run an actual FEA on a part first to make sure that it's going to behave within my experiment constraints I want, and then go back and run a Shape Generator one to actually start my lightweighting or target mass sort of studies that I want to get out of this. But it's always important to remember that if you put garbage in, you're going to get garbage out. So definitely make sure you take some time to validate what you're getting. And for those of you who have used FEA in the past, you know that hand calcs are usually a great way to validate what you're getting. And if you're within 5 to 10% of your hand calcs for your computer results, that's usually a good indication that you're on the right track. Now, the next thing to talk about, though, is your shape generator settings. So here's some different things we can adjust. You can reduce mass by a certain percentage. You can target that. You can try to reach a target mass. You can also maintain a certain member size. And also, if you wanted to adjust your mesh resolution, this is how you do it as well. So the coarser or the finer the mesh that you get will obviously create faster or slower solving inside of this software. And you do get tetrahedrons out of this, for those of you who are FEA nuts like myself. Now, preserve region is, again, one of the more important things to do, to say, you know what, I know we're going to do some lightweighting, but I really, really want you to leave this area alone. I really want to keep this hands off. Don't go near it. So you can do this through either boxes or cylinders, and you can move and size these things accordingly. You can actually click and hold on the arrows to drag them, make them larger and smaller. You can also expand the chevrons of that dialog box and input specific values if you want to do that as well. If you want to set up a symmetry plane, by default, you can use a local UCS, or you can place it at the center of gravity or center of a bounding box. And you can then adjust the symmetry planes simply by clicking on the icons that say for the active planes where you want the symmetry to reside. Once you run the analysis, it's going to go through your criteria, preserving the regions, your symmetry, your loads, your constraints, your material, and it's going to give you the mesh that you see there in that upper image. Now, sometimes you might get some results that throw a cautionary message. It's important to kind of read that to understand what's going on, but sometimes you might get something where your loads aren't fully defined, and that's where it's good to have run it through traditional FEA first, perhaps. Now, once you have that mesh, the next thing you can do is promote this, or actually just print it out to an STL. So you can actually do a 3D print directly of that mesh if you want, just to kind of get that thing printed out quickly to compare it, and maybe take it to a meeting and talk about it. We all like to print things with 3D printers. It's a lot of fun. But if you just promote it into your part model, you'll see this kind of yellowish mesh as a surface overlaying on top of your part. And at that point, you simply have to add sketches and create features to remove the material where you don't have the yellow mesh, essentially. So I'm going to kind of go through a little bit of a supplement here for this and kind of show some geometry, a mesh, the promoted shape, and then the modified solid geometry. I'm going to jump over to Inventor. So here we have Inventor 2020. So fresh and so clean on my install here. Pretty new for this. I'm going to go up here to our 3D Model tab. And here on the Explore panel, we have the Shape Generator command. I should mention this can also be accessed if you go to Environments. And once you're there, you can actually start a new stress analysis. And one of the options in stress analysis is a Shape Generator study. So you can get there a couple different ways, but truly the easiest way is just to click on Shape Generator. Okay, now that we're inside of this, I'm going to look over here at the material. We're going to show all the materials. I'm currently using a steel here. This can also then be overridden if you want as well by choosing Assign Materials. You can choose your override. Of course, if something is outside the criteria for the material analysis, it's going to give you a little cautionary message. Of course, you don't want to make everything out of generic. You know, that's your default material. You know, I can't wait to go to the store every day and pick up a new box of generic. So obviously certain things don't work for that. Obviously wood, water also are outside of the criteria here, so is rubber. Usually the Poisson's ratio throws this off, and that's why you can't use it as a material. All right. Next, we're going to assign some constraints. I'm going to do some pin constraints down here because I'm going to have some fasteners on this. So 4 pin constraints there. I'm going to apply a bearing load to these guys. This will be with 25 pound force. There we go. If you need to change your loads or your constraints, you can do that over here in the tree. I'm going to change my direction here. There we go. It go down a little bit. All right, so those are some pretty standard things for your constraints and your loads, right? So those are the extra ones I talked about down there. Next, we're going to set up a symmetry plane. And I want my symmetry plane to be this one here, and one in the middle. You can see it's highlighted red. I don't really need symmetry anywhere else because that one really makes sense for my part here. For preserve region, you go in here and find this region to preserve. Let's go the other way here. That a little bigger. And again, you can expand these options to get a bigger region settings for this. By clicking on a circular edge, you automatically get that size option there for a circular piece. So there's our center points, there's our display glyph. This is just the color it's going to give that. So I'm pretty happy with that there. The same thing here. Preserve that region. Now, if you make these values the same, it's going to make your results a little bit better. I'm just going to eyeball this though. Just keep applying that. Sort of wish I remembered the direction that I went in, but you just have to keep adjusting it to make sense. Okay, so those regions are maintained. I'm also going to preserve these regions up here all the way through. Make that quite a bit bigger there. One more region here. Maintain that. Very good. All right, I'm going to go to my shape generator settings. And I'm going to say I want a target mass. And before I do this, let's take a look at what my current mass is. So I'm currently at 4.12 pounds, or 4.512 pounds. All right, so go back up to shape generator settings. Let's try to get a target mass of 3 pounds. I'm going to click on mesh view. This can actually compute a nice little mesh here for me. So this is my current tetrahedron mesh that's going to go through and try to adjust. You do also have some mesh settings here where you can change your average element size. That's a fraction of your overall bounding box. So the overall bounding box of this piece, 0.03, is a fraction of that. That's basically the average tetrahedron size. The minimum is 0.2 of that 0.03, so it's actually getting a little bit smaller. The grading factor is going to refer to how these curved elements grade into each other, and our maximum turn angle, which is currently 60 degrees. Now from here, I'm going to go ahead and generate the shape. Go ahead and run this. And you know what? While that one's running, I'm actually going to jump over to my other file, because this can run even though I'm inside of another file. So sometimes that topology optimization can take some time. That's what happens when you work locally on your machine. But what I have here inside of this particular environment is the finished example. And you can see it created this lightweighted model. Now, in order to take this and move it up, you basically promote this. So it's currently grayed out because my other environment is open. But you can choose this promote shape option here to promote this up to the part modeling environment. Now, once you're inside of this, this will be added inside of here as another surface. The mesh feature right there. As you can see, I went ahead and created some side profiles and a front cut profile. Now I'll just use standard techniques here to remove what I don't want. So I'll just go this way. And yeah, I'll get through all. You definitely see some of the new tools here inside of Inventor 2020 in case you haven't come across that. But basically we have some nice tools up here for our palettes. So there's my cut there. Go ahead and turn off the visibility of this mesh feature. And there's my finished piece. Well, maybe close to finished. You might still come in here and tie up some smooth edges, get rid of some sharp corners on this perhaps, but essentially there's my new shape. And this particular piece, let's see where the weight ended up. I got down to 3.364 pound mass. So I can probably keep reducing a little bit more out of there, maybe change my material capabilities perhaps a little bit, but it did maintain those regions that I wanted. So let's go over here and see if this guy is done. Second log window finished. Now that's what I get for jumping between things. But there's the finished model. So let's jump back over to our PowerPoint here and talk about how generative design works with Inventor and Fusion 360. So again, what we just saw was a topology optimization. We got one result out of that. And in order to change that up, I basically had to create additional studies. I had to adjust my criteria each time. And at no time was anything ever factored into its actual manufacturability. Since that part was actually kind of small, you may not have even cared. But if something gets more complex, the manufacturing ability becomes really important. So basically the way this is going to work is between the Autodesk Inventor and Fusion 360, you have something called the desktop connector. Now, the desktop connector is something you can download from Autodesk's website. Let me just turn something off here. Get right back to where I was. Okay, the desktop connector is essentially a smarter version of the old 360 drive tool, if you guys remember that. So the desktop connector can actually come in there and have files loaded from your local computer to the cloud, and they can basically talk back and forth pretty easily. This is something that if you're using Inventor with Fusion 360, that it's going to be using the AnyCAD technology that was added to the newer versions of Inventor. That way, when your Inventor model updates, the Fusion model can update, and vice versa. You can work together in a closer knit connection between those two products. So it's not a traditional AnyCAD technology like you bring in a SolidWorks or a Pro Engineer file. It actually has to use this desktop connector. Now, there was a big update that just happened to Fusion. April 8th actually was a really big update for generative design technology. It streamlined the design workspace for Fusion 360. So in the past, you had a button called Generative Design. You had to click on that. It launched into like another web browser interface, and you had to basically do something somewhere else. And it was more of a technology preview than it was really a core part of the software. So the ability to have this directly as part of a workspace now has made the environment much more streamlined. There's actually now a greater ability to share your design results with other people who are using your Fusion team. Also, a 2-axis cutting manufacturing method is now available in the preview for this, and some expanded functionality for different connector obstacles. So inside of Fusion, you can actually say this can't exceed this boundary because there's a connector in the way. There's also some additional messaging for failed solves it might have, and PreChecks for 5-axis and 3-axis milling constraints, which I'm really excited about that. because it's going to tell you before you actually run your analysis that certain criteria cannot be met based on the type of machines you have or the type of milling operations you're trying to actually perform with this piece. Because even if we create a really neat looking generative design, there's almost always something that has to be machined afterwards or milled on it afterwards, such as maybe boring a hole for a fastener that has to connect into it, because not everything is going to be made from your generative design part. Things are still going to have to connect to it. So let's take a look inside of generative design with Fusion 360. All right, so here we have a little pedal assembly, and our goal for this is to really look at taking a lot of these subcomponents we have down here, which have been created with a lot of thought process in mind. They're high-strength tools, high-strength parts, I should say. Each one of them are individually sourced, manufactured, and created for the purpose of this pedal assembly. And truthfully, there's nothing really wrong with this, but if you're in the race car world, every ounce seems to count. So if we can reduce the weight on this and still maintain the structural integrity of it, we might find ourselves some really happy owners and drivers. Now, this particular set of components here that we're going to replace is actually going to remove about 86 different components from the design. So we can actually really reduce a lot of components here, a lot of complexity, if we can simply get a single generative design part out of it. Now, the way we go about this inside of Fusion is very similar to how we would do it inside of Inventor. You actually have an environment here called a patch environment, and this is typically where you can come in here and create some offset surfaces, where you can then create these as solids that you might use for then preserving regions, okay? And some of this has already been done. I'll go ahead and turn this on and turn off some of my other components there. Yep, so all this green here you can see. It's actually be nice if I just open it up by itself here. We'll let that open. She doesn't want to open right now. Okay. Well, we'll just turn off everything else so you can see it better. There we go. So there you can see the preserved regions. These are the regions we really care about for the connection. Now, what you really need to do during the generative design is you still need to assign constraints to this, like frictionless or fixed or pin constraints. You can assign forces and moments to these things to help it become part of the experiment. Now, where is this actually done? So again, in the past, there used to be a button here between construct and inspect that was called generative design. That's part of that technology preview. Now, it's actually got its own little area here called generative design under your workspace switching. So when I switch over to this, here we go. Just let that load. Okay, you can see I already have some things already assigned to this. So I have a force, I have a moment assigned to this here as well, another force. I also have a fixed and frictionless constraints assigned to this too. And this is done in a very similar way that you would have done inside of Inventor. So you have design conditions up here for those structural constraints, your structural loads. What's really different here about Fusion is when you click on something, it's kind of smart that what it picks up on, and you can pick these from your pull-down list pretty easily. So instead of separate commands, it's, hey, I want to do a structural load, and then you pick which type. So, it's very synonymous vocabulary, but the command flow is slightly different. And if you've never been in Fusion before, that takes just a little bit of getting used to, but it's still actually a pretty streamlined environment. A lot of people say when they get to Fusion, it just doesn't seem like there's a lot here. Well, it's just because they've streamlined the environment so much. Now, once you have this kind of set up there for your constraints, Okay, you can do your preserved geometry. And all these have already been set to preserved. I have 17 bodies that have been preserved. I can actually see that expanded here as well. So I did that just by highlighting these to preserve them. It's a lot easier than having to create those separate cylinders and separate tubes that I had and boxes inside of Inventor. Okay. We also have our design criteria here. So there's some objectives to meet. Let's move this into the main screen. So you can see minimizing mass and stiffness. You can adjust a safety factor in here as well. There's also manufacturing information in here as well. So for milling, configuration 1, I have a 3-axis or a 5-axis option here, different tool directions. You can basically put in a lot of information into this. One of the more important things, though, is to make sure you're understanding what material it's made out of. So if you go to materials, you can do your study materials. Right now, this is actually a steel study material, but you can actually pull from different ones in this list as well. They have different items part of your study. Now, if I made this out of plastic, I don't think any race car driver is going to want to stomp on it with their foot, but essentially you can pick in different types here as well. So plenty of things to pick from. Yep. Next up, we have a PreCheck. And here it's going to tell me that the milling head diameter is large compared to the model size. So I should probably review the milling settings and look at the model size and the overall units. But notice that this is a cautionary message, because if something can be created, usually the human condition is we'll find a way. However, one of my favorite things to tell people, because I came from a world in college where I did a lot of milling and lathe work and bandsaws, nothing made my day better than telling an engineer we can't make that because we can't drill an 1/8-inch hole 20 inches deep. You're out of your mind. So there's some common sense things that do get picked up on here, but if something can be made and you're really dead set against it, you can ignore these kind of messages. They're very cautionary. Next, we have a previewer, which will kind of give us a preview of the mesh. This is really important because it lets you know you're on the right track before you actually run the actual analysis. So it's kind of giving me an idea of how it's going to reduce the material and the kind of blobbish kind of shape that it's going to try to form through. Okay, so I ran the preview there. Next up, we have the option called Generate. So if I were to do this, it's going to stop the previewer. I'm going to say OK. And up here, it has a generative study. And I do have a warning there, which is that same warning I just talked about. And then there's also how many cloud credits this is going to cost. And we'll talk about that in a moment. But you can also come down here and see which account you have. So I actually have a couple of different subscription accounts. And wow, I should really use that one. That's crazy. I love reseller accounts. They're great. But a traditional user account like this one right here has a certain amount of units and how many will be left over when you're done. As soon as you click Generate Study, it's going to consume those units. So again, take stock of what you're doing here and take a close look at what your design is going to be before you actually start to create it. Now, this one has already been done. So I'm actually going to go up here and go to my Explore. So this actually load up my generative results that I've already created for this. Now, I approached this design, this particular one, in a little bit more of a haphazard sort of way. But essentially, I've just produced enough studies here so we can compare some small ones. So whichever one you click on, you can kind of look at the study for that and see what it created. This is nowhere near what I really want it to be. So there's different criteria that I need to go back and set and adjust. And what I learned here, because this is the first one that I had ever done inside of Fusion, was that I better make sure that my preview looks really good, my materials are set, and I understand all my manufacturing capabilities before I click that Generate Study. But if you come back here, you can actually go through the different iterations that it tried to take to kind of see where it got to this result for this particular one. And you can also animate this thing too, to kind of drag it through there. There's also a display you can turn on for different stresses. It's a design space view, so you can see where your constraints were actually at for your preserved regions. This can also be exported, but I'm going to go back here, this little back arrow. Okay, and let's take a look at really what it should have been. So I'm going to go over here to this machining file. And on this one is actually where it ended up when I finished this one. So as you can see, it's got a lot of lightweighting capabilities inside there. I probably really reduced my weight and really maintained the actual stiffness and integrity on this guy. So what's nice about being inside of this is you can actually go through and actually show this being milled inside of here. Let's go ahead and simulate this. Since I am running WebEx, things do slow down here a little bit. In the simulation, though, is we'll show the tools coming in and trying to actually do the milling that was set up on this particular part. Don't rotate too fast. Let that go. So this is where the manufacturability comes in. It wants to make sure you can actually perform this. I'm going to go ahead and pause that. So we would go from all those components down to just this one. Now, we all know that this doesn't look traditional. This is definitely something that it was done, and there may be initial high cost of the additive printing, the additive manufacturing that's going to go behind this, and then the milling associated to it. But the ability to have a lighter weight part inside of something that's designed to be lightweight and also maintain stiffness and integrity can be a very important thing. Also, I can get this probably a lot faster than separating out all those separate components and trying to manufacture, mill, and tolerance everything separately. So there's a lot of intangible benefits there that you might look at that and say, wow, how hideous, but also kind of how cool that I can get this a lot faster. This does break my heart that I can't tell an engineer, no, we can't make something anymore. All right, so let's jump back over to a little bit more discussion here. Now, let's talk about your manufacturing collection. So the technology that we just saw inside of Fusion 360 is only available when you're on subscription and if you do not have an education license. So it has to be a commercial license. And of course, if you are a collection subscriber, you do get Fusion 360 Ultimate. So there's no concern there. It does consume your cloud credits based on users. So each user will get a finite amount of free cloud credits, usually about 100. And as you can see that my generative study there took about 25 credits, you should definitely maybe pass that around to different people in your group. If you, let's say you have 10 licenses, you get 10 users that have 100 credits each. So make sure you use those correctly and efficiently. But if you need to buy more, where do you get these things called cloud credits? And I know it kind of sounded funny here. I thought, like, you know, Star Trek has these things called credits and such, but it just seems kind of otherworldly a little bit. But how do you get more cloud credits? Well, you can buy them directly from IMAGINiT, or you can also get them from the Autodesk eStore if you find yourself running out of these things. So if this gives you more indication that, you know, if you're not on a collection already, that you can definitely have a lot more technology inside of a collection, namely the product design collection here. There's been a lot of things that have been added to it, more than just the Fusion 360 generative design, but also things like the nesting capability, tolerance advisor was added as well, Nastran in CAD, a whole host of things continue to get added for the product design collection that can really enhance your inventor usage or just manufacturing usage in general. One of my favorite new enhancements has been process analysis. So you can actually flowchart a process. Really cool stuff. So one of our last tips here I want to give you is whenever you're using Shape Generator inside of Autodesk Inventor, one thing you should remember to do is to turn off your OLE links to resultant files. Anyone who's ever done FEA knows that it creates these resultant file links. And these can be turned off if you go to your stress analysis settings inside of your FEA environment. You go to the Solver tab and you uncheck this box. Now, you may not think to do this when you're doing a shape generator study, but if you were to create a shape generator mesh, it's actually going to create resultant files as well. So to avoid that, and for anyone who wants to check something into Vault and doesn't want all these extra file attachments going with it, you should definitely remember to turn off these OLE links. And I do recommend you do that in your part templates so that they don't keep carrying forward with the design. Otherwise, you always have to keep breaking them, or you'll check them into Vault and you won't want to deal with them there. So also do this for your assembly and sheet metal files for FEA links as well. But again, for the shape generator, our main focus here, you definitely want to turn those off for your general part templates. So that will bring us to the end of our discussion and demonstration here on generative design. And we definitely want to spend some time here as well at the end for any participants that are on the call that would like to have some questions answered.
Awesome.